All right. So, paint a roadmap of where we're going here today before we jump into material. So at this point, I have those, and actually I can let's get rid of this over here just to make sure we know where they're at. For Thanksgiving, we had a little bit of a hiatus from in-person classes. I posted under the class YouTube page. So where are we at? We are this section. Oops, you don't want to hear me talk. So you should see at the bottom here kind of those two lectures that would have replaced classes we would have had before Thanksgiving, covering panel data. So they're a little bit shorter than the usual lecture. I don't have as many kind of questions coming from people. And to be honest, usually that topic takes us not quite as much time to cover. So you'll have those. I'm expecting that you've watched those at this point. Although if you haven't, I had a in-class quiz, although we weren't in class, that you can take, but the due date isn't until the end of this week. So you still have time, didn't have time there before Thanksgiving, or you prioritize doing different things. Make sure you get out and watch those videos, answer those questions. If I were me, I'd have that pulled up and kind of have the videos. As soon as I see, something that gives me the answer, then kind of answer that question. Now, obviously, I would sit and kind of make sure you watch and then kind of follow through those videos, the entirety of all of them, because anything that I did there is going to be something I might expect you to do on the final. Okay, so that fifth problem set is also kind of turned in. I haven't gotten that graded yet. Problem set 4 should be completely graded. There was an issue with 1 or 2 students, but I had to kind of handle on my own. I'm just kind of catching up from things over the past 2 weeks, but all problem set 4 should be graded and kind of factoring into your grade now. Problem set 5, I've got my graduate students grading that here over the next week or 2. So you should see your grades start popping up for that as well. We will have 2 more things other than this kind of in-class quiz, which is still open, which is I'll post after class today, the 6th problem set. So it'll be the final problem set, as well as kind of that 6th quiz, right? So this problem set will be related to that panel data topic that was covered in those videos, as well as what we go through this week. It'll do at the end of the day next Friday. Now, I'll give you a little bit of a kind of helpful kind of how to organize what you're doing, because I know you've got a lot of other classes. We're getting close to finals. That 6th quiz is meant to be an easy one, right? So there might be a couple questions that are related to content, but a lot of it is going to be questions that there's really no right or wrong answer to. So it's questions about the class, questions about different topics that I'm just kind of trying to get some feedback from you guys. Might help direct me in how I do things, examples I use in future classes. Also gives me an idea, kind of, I have the final kind of written here, but I might take a glance at some of that and think about some questions that I have, kind of which ones I might have a bank of questions, include 5 of the 6 or 7. I might look at those responses to determine exactly which ones I want to use there. So just some feedback that I want from you. So that quiz shouldn't be as difficult as most of them. So even though I posted kind of a set of sample questions here, I wouldn't maybe necessarily put a lot of time into, if you're thinking about taking the quiz. You don't need to go through these sample questions a ton to take that quiz. It's primarily going to just be free and open response, right? So no right or wrong answers there. Now, the set of sample questions would be good at practice for what types of questions I could have used. So it's going to be a really good study tool for the final, right? So these are the types of questions from panel data or instrumental variables, which is what we'll talk about this week, that I could use on the final. So still a good kind of thing to go through as you're kind of thinking about studying for that final. But that 5th problem set, that 6th problem set and 6th quiz will be due at the end of the week next Friday. You'll see them pop up as soon as I get back to my office after class. Okay. So other than that, I did want to mention, and I will post what looks like another week, but it's not another topic. It'll just be finals week, because this week we are going to cover instrumental variables, the last and final topic that I'll expect you to know for the final. Next week will basically just be review. So we're going to have 2 class periods where you can bring any questions that you have over old quiz questions, old sample questions, or practice problems. I'll also get up on the homepage, although you can still access it right now under the Files tab, this practice final It is a little bit light on the questions related to panel data and instrumental variables, which is why I put up that 6th set of practice problems, even though the quiz is more just for, kind of more survey type questions. But this will be a really good study tool for that final as well. Okay. I've also got kind of any formulas that you would need. This will be the formula sheet that I'll kind of print out for you on the final. It opens up here. Well, we'll wait for it. But this will be something you'll have in the final as well. Other than that, so you'll have kind of the practice final. You'll have those set of practice questions, old quizzes, old practice questions. This should really be anything that we would kind of need going into that final exam. I will also mention, next week I'll bring in like an Excel file, which is like a hypothetical grade tool. I'll probably even post it this afternoon, but I'll show you exactly kind of how you can use it. This exam is heavily weighted with exams. So each exam is 32% of the overall grade. So you can start to play around with the Excel file, put in your individual problem set grade, kind of in that category that you see on Canvas, quiz grade you see on Canvas, how many in-class quiz points you have. So after this Thursday, since we still have one more in-class quiz, I promised 10. We have only had 9. Once those due dates pass, and once we've used all of those, I'll kind of put up a total column so you know how many total points you've got from those in-class quizzes. Those are all just extra credit points that will get added into your grade at the end. So I'll have that tool working so that factors all that in. You can start to play around with, well, if I get this on the final, what will my grade be in the class? This one kind of help you direct your studying. I know you've got more than just this class, so if you're on the threshold and it really matters that you get a 80, maybe you really put a little more of your effort, right? As economists, like you should be putting your time where it's marginally the most beneficial, right? And so I want that to be a class. If it's not this class, if you're going to get an A, regardless if you get a 90 or a 75, and maybe you want to take your effort and put it towards another class, right? So I'll get that up as well as we start thinking about that final exam. I'll mention all of this next week and kind of look a little bit deeper into that hypothetical grade tool as well. But here's kind of your resources moving forward. Other than that, any kind of logistic questions about the class before we jump into material here today? Yeah.
Will the practice final be pretty similar to the actual final?
Yeah, so I would say it's comparable to the practice midterm I gave you, and then the actual kind of what that midterm exam looked like. I try to write the questions to be similar types of questions that you would see. As long as, if I'm studying for this final, I'd start with this practice final. I'd go to the sample questions 6, those last ones I just posted. And then after that, I just start reworking through old quizzes and old practice problems, but probably only back as far as nonlinear relationships. So the exam is cumulative in the sense that everything we've talked about since the midterm is using stuff that we've talked about before, right? We're still determining statistical significance. We're looking at the R squared. What does that mean? So we're using a lot of the principles that we learned and talked about before the midterm. It's just now we're using them and adding to it. So the only types of questions I'll ask you is anything that you saw on the practice problems or the quizzes from nonlinear relationships. So quadratic, log, interaction terms, right? We looked at dummy interactions, continuous interactions, some of the data issues or measurement error issues that we talked about, panel data. Those were the 2 videos that I posted. So likely on Tuesday, I'll probably, field questions from all of you because I want to make sure that time is the most effective for those of you who show up. So if you have questions, I'll start with those. But I would imagine some of you might have more questions over the panel data stuff since we didn't work through it together in class and you just have those videos. So we can kind of hammer some examples and questions of panel data a little bit more next week when we're looking at review. And then the final topic, which we'll cover this week, which is instrumental variables. So those are the only topics that I'll be asking you questions on for that final exam. Okay. Any other questions related to the course or logistics before we jump into material here? Is that pretty clear? Yeah, okay. So we have the slides for the final topic, do file, and the data that we're going to be using. So why is this not disappearing for me? Let's see if it disappears here. There it goes. Let's dive into it here, okay? So we've talked about, or I talked about in those videos, a couple things that can lead to bias in our estimates, right? So I'm running these regressions. I'm looking at these slope coefficients that tell me the relationship between an X and a Y variable. The first one we talked about, and it's kind of been a reoccurring thing that's popping up, is this omitted variable bias, right? If I have data that matters that I'm not factoring into my regression, it can cause some omitted variable bias in the variables that I do have, and I'm including in my regression. Now in the panel data videos I talked about, we have things like first differences or fixed effects, which are ultimately kind of the same thing that can deal with this omitted variable bias. But if we don't have panel data, maybe all we have is cross-sectional data. We have a method that we can kind of control for this omitted variable bias as well. Simultaneous causality, I think this I brought up in the panel data videos as well. This is going to be something like if we're estimating a demand curve. Well, I know that when the price is higher, people are going to buy less. But if there's less out there on the market, that might also result in people thinking about moving up the demand curve or a higher price, right? So which one of those is causing the other? It gets a little bit hard, right? There's some simultaneous causality there. So that can cause some bias in our estimates. We're also going to have errors in our variables. So we had measurement error in the dependent or independent variables. We can solve for some of that using instrumental variables as well. Okay. So I'll sometimes reference this as IV instead of instrumental variables, just because instrumental variables is a lot to say over and over. So IV or instrumental variables is going to be one way we can eliminate all of this bias and make sure that the slope coefficients we see are accurate. Okay. So just some terminology before we really dive deep into these instrumental variables. So the general idea of what we're going to be doing is we're going to want to break our X variable down. And I feel like moving, so let me see if I can plug this in here. We're going to break our X variable down into two components. So we can think about one of the components is going to be, maybe if this works. Maybe I won't be moving around as much. See if that works. Not going. There it is. Maybe that's not gonna work. So I guess I'll be standing here a little bit more. The first component of this X variable that we're interested in, so we're interested in how it impacts our Y variable, right? It's going to be correlated with the error term, right? So it's going to be correlated with all of these other things that are going to impact Y that we don't have data on. So this is kind of the idea of like an omitted variable bias, right? That X variable we're interested in, it has omitted variable bias if it's correlated with anything else that's in that error term, right? Now we also have a part that's uncorrelated, right? Or it's not correlated with the error term, right? It's correlated with other things outside of our regression. So what we're going to do is try to use the variation in X that's not correlated with our error term. It's correlated with all of these other things that don't matter in our regression. Okay? And we're going to use that relationship to then eliminate the bias when we're estimating that slope coefficient on X in terms of its effects that it has on Y. Okay? So the terms that we're going to start using here, we have two different types of variables. One's going to be endogenous. So this is going to be if something is endogenous, right? It plays a role, it matters, it's impacting something. And so in a variable that's endogenous, it is going to be correlated with the error term, right? It's having an effect on that error term. It matters. If we have an exogenous variable, that's going to be something that's completely uncorrelated with the error term, right? It's exogenous, outside of our linear regression, outside of our model. So we're going to have variables that are both correlated with the error term and then uncorrelated, right? So endogenous within, so it matters. Exogenous outside of, it doesn't matter. So what we're ultimately trying to do is when we're estimating the relationship between, let's say, do I have it here? No, I'll write it down and come back here. When we're estimating this relationship between Y and X, right? We're going to try to find what we call an instrument that helps us eliminate the bias that exists in beta 1. So remember when we said we've got this estimate for beta 1, it includes the true effect. Then, right, we have all this other stuff that kind of was our omitted variable bias, right? So what we want to do is find an instrument that will help us eliminate that omitted variable bias or simultaneous causality bias or our measurement error bias. So we're going to be looking for an instrument. We're going to call that variable Z. We need a couple conditions to be true about variable Z that allows us to use it to eliminate that bias that existed in our coefficient estimate for X. So what are those conditions going to be? Well, the first is that we need this instrument to have what we call relevance, right? So we need our instrument to be correlated with this X variable we're interested in estimating the relationship of between that X variable and Y. So when we say it has to be, have a relationship with it, essentially we're saying that the covariance is something other than zero. So we're looking for an instrument where the covariance between the X variable we're interested in our regression and this instrument Z is something other than zero, right? They have some relationship between the two, or there is some relationship between the two. Now, the second condition is that this instrument is exogenous. So it's not that it's exogenous to X, right? We need it to be endogenous to X, right? Have some effect on X. But we need it to be exogenous to our Y variable. So technically speaking, we need that instrument Z to have a covariance with our error term in our regression that's equal to zero. It's not correlated at all with our error term. Another easier way of thinking about that, although it's not quite technically correct, but for the sake of what we're doing in this class, it's easier to say it this way. When we say it's exogenous to Y, we're just thinking about something that doesn't have any correlation with Y, right? So our instrument has to be correlated with X, but uncorrelated with Y, right? Now, technically, like I said, the instrument has to be uncorrelated with the error term in our regression for Y, but those two things are very similar in the way we think about them. So if it's easier for just think about just uncorrelated with Y. Okay? And this is in my way, so let's get this out of here. So if I had something that was exogenous to Y, why would I not want to be including it in my original regression? So if I was thinking about something like this, and I have this instrument Z, and I think that the covariance, to make it easier, between Y and Z is equal to zero. If I were to include Z into my regression, well, what's going to be true about this coefficient? The covariance between Y and Z is zero. The covariance or the coefficient should be zero, right? Or if I look at the statistical significance of this coefficient, it should be statistically insignificant, right? Now, what's the problem? We said when we just start adding variables in to our regression, well, if we think about our adjusted R squared, we know that when we add in variables, our R squared is going to do what? Increase, even if the variables don't have statistical significance, right? We can just dump a bunch of control variables in and we'll always see the R squared goes up. Now, we're thinking about here, we have like the sum, the differences between Y, predicted Y. There's some other stuff up here, but really what, and actually here, I think it's what, n minus 1. And then what's down here? I forget, it doesn't really matter because the point that I want to make hinges on this part right here, right? So as I add in more variables, if they have no statistically significant impact or they're not having any predictive power, what's happening between the actual Y's and my predicted Y's? Well, my predicted Y's aren't any better. This isn't changing. But as I add in more variables, hey, was the number of variables we had goes up. So I'm subtracting a larger number. So this denominator goes down. If the denominator is smaller, this fraction goes up. What's happening to my adjusted R squared? Well, now the denominator is larger. This is going to go down, right? This is kind of a little bit of review when we talked about just dumping in more variables doesn't help us, right? It's going to lower that adjusted R squared. It's basically just additional noise. It doesn't have any impact on predicting those Y values. So if we can find this instrument that is completely exogenous to Y, it should be a variable that we weren't even including in our regression. So that'll be a good thing for us in here in just a second. Okay. So we want it to be completely exogenous to Y. Okay. Just looking a little bit familiar here, hopefully. All right. So those are our two conditions. Endogenous to X, exogenous to Y. It's the shortest way of saying that, right? Here's a little more technical way of kind of saying that, but so there. What we're going to do is if those two conditions are met, we have a way that we can use this instrument to eliminate the bias. So that we're going to have to actually run two regressions now. So the first regression, and this is just a way that we can kind of notate the differences between these regressions, will be I'm going to try to predict my X variable. So the original regression that I had written up there where we were predicting Y with X. I'll take those X values and I'm going to try to predict them with different values of my instrument, Z. So I'll run this regression. I can come up with coefficient estimates for pi 0 and pi 1. I can then use those to come up with predicted values of X. So these won't be the actual X values, these will be the predicted values of X. Once I have those predicted values for X, my second stage, so this is like kind of combined, it's two steps, but this is my first stage. Here's my first stage regression. Using those regression results, I come up with my predicted X values. Now my second stage is going to be, I use those predicted X values to then run my original regression where I'm trying to predict Y using that X variable. It's just now instead of using the actual values for X, I'm going to use the predicted values for X from my first stage. Okay. So we're now going to run two regressions, but once I get to that second regression, the estimate I see for beta 1 should now be unbiased, right? Before we talked about it included things like omitted variable bias. If I use this method, and I'll try to kind of show you the math and prove to you why, I can eliminate that bias. Okay. And I'll show you how we do all this in Stata here in a second. Any questions on this up to this point? Okay. So, just to kind of give you a little bit of an insight into why this works. Right? Let's say I was interested in the covariance between Y and Z. Right? So this is the covariance in between my Y variable and that instrument Z. Well, I can just substitute in for Y my original regression equation, right? Where I was trying to predict Y using the actual X values. So it might not be completely clear, but I can kind of, it's like when I'm taking the covariance of things, it's like I can distribute, if you want to think about it that way. The covariance of something plus something else is the covariance of this with this, plus the covariance of that with that. So I've got my covariance of the intercept with the instrument, the covariance of beta 1 times X with the instrument, and the covariance of my error term. Well, the intercept is always the same value, so its covariance with anything is always going to be 0. It's not impacted by it, it is one value. So this covariance will always be 0, so that's eliminated. Now, if I rearrange this, or if I think about these other two components, we said one of our conditions for our instrument, and this is where the technical way of saying it matters. I said the less technical way is that it's exogenous or that it doesn't impact Y. Really what we needed was that it's correlation with the error term for our Y equation and the instrument was equal to 0. If that's true, and like I said, another way of thinking about that is just that it's uncorrelated with Y. If that's true, this component gets eliminated as well, and we're left with this. So why is this nice? Well, here I've got the unbiased estimate for my slope coefficient from my original regression, which is what I was interested in, the relationship between X and Y. I can just rearrange this a little bit and notice the unbiased estimate will simply be the covariance between Y and Z divided by the covariance between X and Z. Okay. So why does my first and second stage give this to me? Right. So I don't think I have anything here. Yeah, we'll come back to this. I am not going to expect you to reproduce what I'm about to do, and I'm going to kind of hand gloss over a little bit of it with the math, but I think it will kind of help give you an idea about why running our two-stage least squares regression, which is the technical term for it, running these two stages, will give us this unbiased estimate, which is the same thing as the covariance between the instrument and our y variable divided by the covariance of x for your instrument. So. There we go. So let's say I've got this. And this was like the error term u, just kind of to notate it's different than the error term from our other regression. So if I think about what the estimate of that coefficient is, it's going to be the covariance between x and z divided by the variance of z. That was kind of a simple way. When we didn't have any other additional controls, that's what our slope coefficient equation was. It was the covariance between these two variables divided by the variance of our x variable. So if I then think about, okay, if I were to run this regression, where I've got, I should be having, I want to use my predicted x values here. So I'm going to have what? I0 plus I1, and then different values for z. Well, this kind of gets absorbed into my intercept term, so I can think about the coefficient that I'm really going to see here is going to be this guy right here. So what was this? Well, I'm looking at what would the slope coefficient be here? So beta 1 would be the covariance between y and z divided by the variance of z, but then it's being multiplied by this pi 1, right? So I'm kind of thinking about, I guess I could try to like just move this around and think about, okay, what is that actual slope coefficient? It's the covariance between the actual thing that's changing, this z variable, and then kind of my y variable here. Well, what is this? Well, let's see if I save myself enough room. So I've got covariance of y and z over the variance of z divided by, we had an equation over here, covariance of x with z over the variance of z. This would cancel, and I'm just left with the covariance of y in the instrument divided by the covariance of x with the instrument, which is what I was saying right here. All right. So as long as that instrument is exogenous to y, when we do that two-stage least squares regression, we're going to end up with that slope coefficient of beta 1 being the ratio of these two covariances. And I'll prove this to you with some data here in just a second. Questions? Well, like I said, we won't go through this every single time, but that's kind of where that comes from. Now, before we go to Stata, just a couple things I wanted to mention here. We won't talk about weak instruments yet. Everything I've done at this point, I was assuming we don't have any additional controls. It's just because it makes the math a little bit easier. We can include additional controls and everything will still hold. We still need the same conditions to be met. We can still use the same procedure. But when we run our first and second stages, these other control variables, we'll call them W that we're adding in. We need to make sure we have the same controls in our first stage as we do for our second stage. Okay. Now, one major reason why this is important, there's some more technical reasons as to why, but think about when we talked about like data sets with missing data. What could happen if let's say I only had 2 control variables in here. I was trying to predict income and I included age and, I don't know, education level. But then down here in my second stage, I included age, education level, and what's another good one we could do? I don't know. The number of previous jobs they had. Well, maybe for some people, we didn't have information on the number of previous jobs. What would then happen between our first and our second regression? If that new variable that we had in the second stage regression, we didn't have in the first, all the missing values, what is Stata going to do to those observations? If you have missing values, Stata just ignores them, right? It drops those observations. Can't run the regression using them. So what would happen? The number of observations in our first and second stage would be different. We'd essentially be using 2 different data sets. we need to have the exact same data set in our first and second stage. So one way that we can kind of make sure that's occurring is using the exact same controls in both, right? If we don't, we can get some things happening where we won't end up with an unbiased estimate. So any controls W that we use in our first stage, we've got to make sure we use them in our second stage as well. Okay? But if we do that, all of this stuff, all of this will hold, the math just becomes a little bit trickier, right? All right. This is a lot of more technical things, kind of focus a little bit more on how we actually put this into practice, which is what we're now going to do. Right now, kind of jump back and forth. So I think I had this health data, which is what I posted up, hopefully. Yeah, IV Health, the data set I put up on Canvas. So I'm just going to open up that file. Right, you'll have to change the file path wherever you're kind of downloading that file and opening it up. But once we have that, I'm going to have this very naive regression. So I'll write this out here in just a second. But I'm going to try to predict medical expenses. And I use this to kind of prove we can do instrumental variables with log linear models. It doesn't matter, right? We can combine it with any of those types of models. But here's my naive regression where I'm going to say, okay, how does someone's actual medical expenses, so the amount of money they pay, right? This is the amount of money they pay out of pocket. How is it impacted by whether or not they have health insurance, controlling for their age, previous illnesses, that's what the illnesses variable was, and then what their log of their income was. So what we're thinking about doing, kind of set us up here. We're trying to predict the log of our, or think about our medical expenses. And the variable that we're really interested in, the relationship between medical expenses, is whether or not the individual, and this was just a dummy variable. So you can do this with continuous variables. You can also do it with dummy variables. Here we just happen to have a dummy variable. So it's whether or not they had health insurance. And then we had what? A bunch of other additional controls. Okay? So this was our Y variable. This was our X variable of interest. And like these were our other controls, right? Just to kind of match up with what we were doing in the slides. So in the data set, we also had this variable that I thought might be a good instrument. Might not be. We'll kind of investigate it here throughout the rest of the class. But this instrument that I was thinking about using was the ratio of Social Security income, right, to medical expenses in that state. So how much money you could expect kind of from Social Security, excuse me, like the amount of your, so this SSI ratio is like how much of your income the Social Security replaces. So a higher ratio is better, right? They're giving you more of your original base income, right? So automatically I'm thinking, okay, well, if the state is giving me a lot more money, I would expect that would make it more likely I actually have health insurance, right? If they're giving me more money, it's more likely I'm going to decide to pay for health insurance. However, state level policies don't really impact what my personal medical expenses are, in the sense of like, I'm not getting Social Security, right? My medical expenses are completely unrelated to how much Social Security income is given in the state. So I thought this might be a good instrument where it could be related to a lot of individuals in our data set, their decision about whether or not they get health insurance. Even if they aren't getting Social Security, let's say I'm 60 years old, I might make a very different health insurance decision if I expect in 5 years to get more money. So it's likely going to be, we said, endogenous to our X variable. But, and there's probably maybe a story you could tell. So this is where instruments, people always try to poke holes in them. And I'll try to bring in next class a couple academic articles that have used different types of, because there's some kind of neat ones and some like ones you wouldn't think of, some interesting instruments. But, you know, I can't think of a story that says that state level policy on Social Security income and how much of your base income that's kind of replacing is related to individual medical expenses, right? So my idea here was that it's likely that this instrument is going to be exogenous to Y, which these are the two traits we needed for a good instrument, right? For this two-stage least squares regression to work. Okay. Any questions on this setup before we dive back into the data here? And this may not be the perfect example. As I said, we'll kind of investigate whether or not this is a good instrument here in a little bit. So I run this naive regression where I haven't used the instrument yet. And I get this really weird, well, I think it's weird. Get this kind of weird estimate. So if I have health insurance, I actually end up paying more in medical expenses. Isn't that what health insurance is supposed to do? Actually make me pay less, right? Well, what might we have going on here? Well, I've only controlled for age, illnesses, and income. There's things I can't control for an individual, like the fact that you might be more concerned, about your health, right? That you're more health conscious. That will make it more likely you get health insurance, but also much more likely you're going to routine medical checkups. You might go get things checked out. You've got a weird rash, maybe you go in and get it checked out. Well, all of those things would also make it more likely if you're making more doctor's visits that you're going to have higher expenses, right? Even if you have insurance. And so there's all these other omitted variables we have that are causing a bias in our estimate. So how can I eliminate that bias? So our naive regression, and it's statistically significant. Looks like health insurance actually leads to me paying more in medical expenses. So why the hell am I paying for it, right? Well, let's take a step back, right? We know there's probably some omitted variable bias. So let's do this kind of instrumental variable thing. So here's my first stage. I'm going to try to use this state level Social Security income ratio as my instrument. So here's my variable Z, my instrument. Here's my X variable I was interested in, its impact on that Y variable. I was interested in health insurance, having health insurance impact on medical expenses. So here's my first stage regression. I'm then going to, we've done this before with just in another context, use my predict command. Once I have those regression results, I can use that predict command to create this new variable. And I think I accidentally saved this from my other class. So here, just so that we're working off the same one. Let me download this. And I'll make the same edits here in class and save it and I'll re-upload it. But okay. Just to make sure we're all working out the same thing. Oh, is it not going to let me access the downloads here? Can I access desktop? Well, maybe I won't do that. Give me 1 second here. How can I get around that? I can. Original files saved. Yes. Okay, good. This is the one I posted. So we've got that file opened up. We already ran our naive regression. So we are here where we're going to run that first stage. Right? So I run that first stage regression. I can see that Social Security income ratio looks like it has a statistically significant impact on whether or not someone gets health insurance. So if I expect that Social Security is going to replace a higher amount of my income, I'm going to have more money coming in from the government. It looks like it makes it less likely the person decides to get health insurance. So this might be that they're not worried about medical expenses because they expect to have more money to be able to cover them. So there is some relationship between my instrument and my X variable. It's statistically significant. So I would say this looks like it's endogenous, right? My instrument is endogenous to my X variable. So the next thing I'm going to do is use that predict command. So this is the file I uploaded where I just called my new variable first stage. And then this comment XB was said, take the actual values for X, take the coefficients from that regression I just ran, and predict this Y variable, which was our X variable, right? Just predict the variable that we were running the regression for we had on the left-hand side. Now, I'm going to change this around a little bit just to make it easier to follow. So this was naming the variable predicted health insurance instead of just first stage, because that's kind of hard to remember exactly what that represents. But it's going to be from our first stage, our predicted value of that X variable health insurance. So I'm just kind of renaming it here, right, in these two stages. So I'm going to run this regression and then predict that those X values. So run that. Now, if we go to the data, so it's predicting those X values. Now notice the original X variable we had, it was just 1, 0, whether or not I had health insurance. So with a dummy variable, our predictions are going to be something different than that, right? It's kind of the likelihood I had health insurance. So we've now got our predicted values for X. My second stage was I'm going to then run the regression of the Y variable that I originally was interested in, medical expenses. But instead of using the actual X values, I'm now using those predicted X values that came from my first stage where I was using that instrument. Okay? So now this is my second stage, right? So I'll run this regression. Now, compared to my naive regression before, remember we had 0.07 was the slope coefficient we found. Now, the slope coefficient we find on health insurance, not only is it not positive, it's negative and quite large in the other direction, right? So now having health insurance looks like it actually decreases the individual's medical expenses and at all of our conventional statistically significant levels. So when we use this two-stage least squares regression, we've eliminated the bias that existed. So what must have been the case when we were running this very naive regression where we had log of our medical expenses and we were trying to estimate that relationship between having health insurance. The estimate we were seeing from our naive regression included the true effect, but it also had, all these, and really it'd be the bias of one omitted variable, the bias of a second omitted variable, all of the omitted variable biases we had, our estimate we were seeing, which was like 0.07, was including all of those. Once we use this two-stage least squares regression method, we've eliminated all of that bias. So it must have been that these bias were positive, because once we eliminated them, the true effect that we found was like negative 0.85. So we now have an unbiased estimate by using this two-stage least squares method. Any questions of what I'm getting at here? Before I keep moving. This hopefully I understand it's a little bit black boxy, but we're kind of seeing that sign completely flips, right? So that was our kind of method for using that first and second stage. There is a shortcut, and I tried to put kind of the general form right here. So one thing I haven't mentioned yet is I was also including additional controls. So I said we can do all of this instrumental variable stuff with additional controls in there as well. The shortcut that we can use is this IV regress command. And then there's some other, it's like a built-in package. It's got a bunch of like different code behind the scenes that we can't really see that it then tells Stata it can use. So what we're going to use is this two-stage least squares. That's essentially our instrumental variable running these two stages. Okay? You then tell it your Y variable, which was medical expenses. In parentheses, you then tell it the variable that you want to instrument. So the variable that we were instrumenting, right, we were trying to come up with an instrument for, was health insurance. The instrument itself was this social security income ratio. So this will always be the kind of format you use. Y variable, the variable X you're trying to instrument, and then the instrument that you're using. And then you include any additional control variables that you want on the right-hand side there. Now, I added this in, but let's just eliminate this for a second, and I'll kind of mention that later on. Okay? So here's kind of a nice little shortcut. It's going to run the first stage, make those predictions, then run the regression using those predictions, and do that all behind the scenes. So if I hit run here, I don't see the first stage, I only see the second stage. Now notice, what do I end up seeing? The exact same value, right? Negative 0.8522, all right? So I get the exact same coefficient estimate. Now, any questions on that before I keep moving? It's just a shortcut of doing the exact same thing that I just went through with the two different stages. Now, I'd be amiss if I didn't point out, and we won't really dive into it in this class, but this built-in IV regress has some options that you can play around with that account for things like heteroscedasticity, which we didn't use when we were just using that method where we actually ran the first stage, made the predictions and the second stage. So even though we end up with the same coefficient estimate, notice what happens to our standard errors. They're a little bit higher. So I won't ever ask you a question where I would ask you to do both of these, or if you chose one or the other on the problem set, it would lead you to different rejection decisions. But when you are looking at this kind of, you see like the more black box method, it is doing something a little bit different behind the scenes that kind of controls for some of that heteroscedasticity and actually gives you more accurate standard errors, which here they're a little bit higher, right? But not much, right? That test statistic of 4.3 and 4.56, pretty close, right? But I did want to point that out just so you're not like, well, it's not doing the exact same. No, it does something a little bit different that's going to change our standard errors, but that's kind of outside the scope of what we're going to talk about in this class. Here's like a nice shorthand way of getting at that slope coefficient, which is what we're interested in. Okay. So any questions there before we keep going? So I can't remember the exact, this is where using some of these data sets, I forget exactly. I should pull up the what do they call them? Like the dictionary files where it tells you exactly what all these variables. From my memory, firm location has something to do about, was the individual with, do they have a hospital in their county or no? Do they have a hospital in the city of their address or something like that, where they had like basically more medical things available to them. So once again, like the firm's decision shouldn't be about where they're located, shouldn't be impacted at all about what the actual expenses are. But it might be more or less likely that someone gets health insurance if their firm, you know, there was a health firm relocated closer or far. So it could be an instrument. It's just something else that I had in the data. We could kind of, I just wanted to show you. You could do the same setup, but instead of using this social security income ratio, you could use this firm location if you think it was a good instrument. We can kind of see here, it also suggests that the effect is going to be on health insurance is actually negative on your medical expenses. Now, if I'm looking here, which of these would I maybe say is a better instrument? So just like when we were talking about nonlinear relationships, sometimes I would ask you, like in the problem set, what are two things that suggest this model is better than the other? So that was like the R squared and then the statistical significance of your coefficients. Same kind of thing here. The first thing that we would look at what's a better instrument is which one of these estimates is more statistically significant. Well, looks like when I'm using firm location as an instrument, my test statistics 3.5. Here, when I used this social security income ratio, it's 4.3. So this one looks like it's a little more statistically significant. So maybe a slightly better instrument. Now that's not a great way of identifying it. We'll talk about another way, which is we're actually going to use something called an F statistic to determine whether or not it's a stronger instrument. But that is one thing we could look at just up to what we've done up to this point. Any other questions before we keep moving? So I can do this with multiple instruments. If I'm thinking about, do I have this later on? Yeah, I've got it down here. So I'm going to skip over this for just a second, just because we're talking about it. When I'm thinking about weak instruments, or how do I identify what might be a good instrument, a really good first way of kind of identifying instruments might be, I need to identify something that is going to be endogenous to my X variables. So all I'm going to do is look at the correlation of these different variables that I think might be exogenous to Y. I don't think that they matter with medical expenses at all, but I think that they're correlated with whether or not someone decides to get health insurance. So if I just look at the correlations of these variables with health insurance, that can be like a very quick, dirty first glance into what looks like it's a better instrument in terms of, is it endogenous to X, right? Is it endogenous to the decision to get health insurance? Well, here that social security income ratio, its correlation with health insurance, 0.21 versus that firm location variable, only 0.11. Now, once again, negative, positive here, we just care about the magnitude. And so it looks like that social security income ratio might meet that first condition of being endogenous with health insurance, our X variable, a little bit more. So simply looking at that correlation coefficient can be a way that we identify what might be the best instrument to meet that first condition. Now, what could I do to see does it meet my second condition? Well, instead of typing it into the command box, so I can save it for you if you want to go back. Is it exogenous with medical expenses? I could do the same thing. So correlate that SSI ratio and firm location with my log medical expenses. Which one of these actually looks like it's more exogenous to my Y variable? Ooh, well, their firm location is a little bit more exogenous. And they're like, which one would I use? There's not like a hard and fast rule, right? It'd be great if this was flipped and that SSI ratio was both more exogenous to my Y variable and more endogenous to X. But sometimes, like anything in economics, sometimes the answer might be, it depends, right? This one variable is a little bit better at satisfying the endogeneity. Excuse me, the endogeneity condition. The other one's a little bit more better at satisfying the exogeneity condition. And with those, just simply looking at the correlation coefficients is one way we could do that. All right. Any questions on that before we keep moving? Where are we at in time? We started at 11:30. Okay. I'll pick up my pace here a little bit. So the next thing that we're going to talk about are weak instruments, right? So I kind of already mentioned some of these things we can look at, just the correlation coefficient, statistical significance. We can also look at these F statistics that are going to come from our first stage, right? So these F statistics essentially tell us how much of the variation and why is our regression actually explaining. It's kind of like a test statistic associated with our R squared. Okay? So a general rule of thumb, if you have a strong instrument in terms of is it endogenous, is if the F statistic from your first stage is above 10. Now, we also can look at the p-value. So I'll show you how to find both here in a second, but this is kind of our rule of thumb. As long as that first stage has an F statistic greater than 10, it's a pretty good instrument in terms of meeting that endogeneity, not concern, endogeneity criteria, right? That first condition. Okay? So let's go back to our example and kind of look at these, okay? So when I ran these IV regress commands without that first on the end, I can include this additional thing, which is comma first. If I do this, it'll show me the first stage regressions, okay? So here, I'm gonna run both of them. It's the exact same thing we just did. I'm just gonna add on to the end, comma first, so it shows me my first stage regression. Okay? So I hit run here. So when I was using that SSI ratio, where's this at? There we go. My first stage results, it now shows them to me. So it doesn't do it all behind the scenes. And it tells me the F statistic for my first stage, or basically how much of the variation in that health insurance variable was my regression using SSI ratio explaining. And kind of not just how much, but what test statistic was associated with that. And so the test statistic we had there was 185. Now the p-value, if we use if we don't use IV regress, so I go back up here and I kind of use this manual method. Oops, I want the first stage, not the second stage. Oh, actually it does give me that. Yeah, so I got my F statistic. I can still get the same information, right? But if I am using IV regress, I can just put comma first and it'll tell me that as well. Okay? So I'm gonna run these again. So we've got our shorthand. So 185, where is it at? Oh, did I go too far? There you go. I want my first stage. Oh, I'm running the wrong code. I ran the one without first, sorry. It's down here farther. Here we go. These are the ones that we were using. So scroll back up. Okay, so there's my first stage regression when I use the instrument of SSI ratio or Social Security income ratio. F statistic of 185. If I then compare, so it's well above 10, so it looks like it meets that endogeneity concern. If I used firm location, the F statistic from that instrument is 146. Now the p-value associated with that is still 0. Remember, when we're looking at F statistics, it's going to be something in which we know, just like when we're looking at R squareds, when we add in more variables, we always know the R squared is increasing. So essentially, we have this F distribution that had this long right tail. Now, whatever F statistic that we see, our p-value is simply going to be the area to the right. So what is kind of a more statistically significant instrument? Something that has a higher F statistic. So the instrument that had an F statistic of 185 instead of 146 or whatever it was, that's going to satisfy our endogeneity condition a little bit better, right? Because it's going to be more likely we can reject the null, or we can reject the null at higher levels. So we're looking for what instrument has a higher F statistic. In our example, that was going to be, scroll past it already, there it is, that SSI ratio. Okay. So looking at that first stage results, we can look at the F statistic. We also said we could look at kind of the statistical significance of that instrument. So here we had what? 14.11 was our test statistic. Firm location was only 7.19, so a little bit less. Questions on that? So we use our first stage results to kind of compare what instruments are better. We can look at both the F statistic, but then also the individual statistical significance on the instruments, right? Two ways, kind of like we had two ways of identifying what model is better. All right. So one thing I did gloss over here, we'll go back up and look at, but I kind of wanted to make the point. I told you earlier that the unbiased estimate should simply be the covariance between Y in your instrument divided by the covariance of X in your instrument. So we can test to see if that's the case, okay? So I'll show you something that might seem like, oh, I'm lying to you, right? So let's run this regression where we were looking at Social Security income ratio. We had the estimate of negative 0.85. Well, I told you that if you were to look at the covariance, so we could use that correlate command, this tells me the covariance between my Y variable and the instrument, right? Medical expenses and Social Security income, and the covariance between my X variable and the instrument. If I then take a ratio of those two, so I could kind of run these, I get what? 0.0312, negative 0.03797. I take a ratio of the two, I get negative 0.8217. Well, that's not quite the same as what I got here. Well, why is it a little bit off? This really only holds if I don't use any additional controls, right? So if I were to run that IV regress where I don't include these additional controls, I should end up getting that exact same coefficient as if I took the ratios of those covariances. So when we add in more controls, it will be the ratio of the covariances, and there will be some additional components there as well, right? Because it'll depend on what the instrument's correlation was with each of those controls. It'll got kind of added in there a little bit as well. So, it looks like it doesn't, what I showed you earlier only holds for if we don't have any W variables, right? No additional controls. right? But even if we do, you can kind of see, I mean, it's pretty close to negative 0.85. It'll be close, it'll just be a little bit off. Okay. And there's ways to actually account for those controls that we just aren't going to dive into in this class. Okay. So if I were to ask you a question like this on the exam or practice problems or something like that, I would give you one that doesn't have any controls. I might then ask you, without running the two-stage least squares regression, what's the coefficient? You could find the covariances and take the ratio of the two. Okay. Any questions on that? Okay. All right, so let me think. We've got 15 minutes. What else do I want to do here? Oh, I think we can at least touch on this, and then we'll do another example next class. So we also have, whoops, I'll do that in a second. We've got one more test we can use for endogeneity to see whether or not we should be using an instrument. So here, if I'm thinking about my first and kind of second stage, instead of running it with the predicted X values, I can do like a first stage regression. And then instead of predicting X, I can predict the error term from my first stage. If I then include the actual X values and the error term from my first stage, if I can reject that slope coefficient associated with my error term, then what I'm actually saying is X is endogenous and I need an instrument. So just to kind of see this with data, I think this will make a little bit more sense. Let's say I run that first stage regression where I'm trying to predict health insurance based off of this state level policy. Okay. So I run my first stage. I'm then going to use that predict command, but instead of comma XB, which would give me predictions for that variable, my dependent variable, I'm going to use comma resid, which basically is telling me the residuals, the difference between the actual health insurance variable and the predicted health insurance. So I'm going to kind of save this as a new variable called first stage residuals, or if you wanted to call it first stage error. So once I have those predicted first stage errors, right, that's kind of that Q hat, I'm just going to include those into my regression. So the same second stage regression I had before, where I'm now, instead of using the predicted health insurance, I'm using the actual health insurance, but I'm using my predicted residuals. Now, if I run this regression, I'll see that the coefficient associated with those residuals, I can reject it at every conventional level, which that's essentially telling me is the errors from that first stage, excuse me, are correlated with my Y variable. So that means that that X variable must be endogenous, or I have some endogeneity concerns. I should be using an instrument, right? So there's another way of kind of testing for endogeneity. We can, instead of including the predicted X values, include the predicted residuals. If we can reject the null, the predicted residuals are in fact related to our Y variable of medical expenses, that's evidence that we need to use an instrument, that we should be instrumenting with whatever we included in that first stage, which was the Social Security income. Okay. So another kind of test, and we'll review this a little bit more in depth next class. In fact, I've got a whole other example where we're going to work through basically very similar things, just a different way, different example of instrumental variables. We'll kind of rehash basically the exact same thing. So it's not going to be like new material in the sense that we're not going to be going through any new topics with instrumental variables. We're just going to be talking about exactly what we talked about today in the context of another example. And I might add in a couple little things here and there. We do a little bit different than we did today, but it'll be primarily the same kind of setup. Okay. So if we're not feeling super confident with it yet, it's okay. We're going to go through a whole nother data set, work through the exact same kind of topics and questions, identifying endogeneity, exogeneity, whether or not those conditions are met, running the actual regression, identifying, where's that? Weak or strong instruments. And we'll kind of look at maybe some shorthand cuts that we didn't talk about, or shortcuts that we didn't talk about today. Another example that I looked up, let's see if I, just to kind of give an idea about, like in practice, what economists are using for instruments. So there was someone who was trying to predict lifetime earnings based off of like highest year of education. And this was a while, they were using some older data. And so this is like had people that, a lot more people that didn't have like a high school degree. And so their thought process was, here was their Y variable, here was their X variable, right? They're interested in getting an unbiased estimate for beta 1. The problem is people that decided, what are the types of people that decide to stay in school longer? People that probably are going to have, it's going to have a higher marginal effect for, right? So there might even be some type of like a simultaneous causality. It could also be that a lot of the characteristics that are correlated with, do I have stay in school longer? Like maybe my parents have more income, right? Maybe that also then impacts my future income opportunities. So there's going to be a huge omitted variable bias as well. So the instrument that they came up with was, and this is kind of maybe starting to show you, state compulsory education laws, right? So a lot of instruments will be things that are like state level or country level policies, or just things that are random, right? So here, state level compulsory education laws. So like I said, the data they have was a little bit older. So some states you could drop out when you were 15 if you had like a job or parents sign off on it. Some states you can drop out at 16, etc. Right? There's variation. So our conditions, does this variable meet our endogeneity condition? Well, if states have compulsory education laws, is that going to be correlated with the years of education someone is getting? For sure, right? It's going to force some people to have more years of education. So there likely is going to meet that endogeneity concern. Does it meet our second concern, which is that our instrument is exogenous to Y? I mean, maybe you would have to think of a pretty convoluted story as to why state level compulsory education decisions would impact kind of the earnings of an individual. Now, so the authors would argue that it is exogenous. Why could you think about maybe this isn't the case? Yeah.
When it comes to like finding you could work on something instead of spending like 8 hours learning quote unquote meaningless material that you're not going to use in like 10 years.
So there you could think about so it would have to be how the state laws are impacting earnings through things other than years of education. So it would have to be things like if state compulsory education laws were passed at the same time as, I don't know, laws that made it easier for unions to exist. Well, now, anytime you have a state compulsory education law goes hand in hand with union, we know that's going to impact earnings. In fact, there was one paper, and I'm not going to remember. Have any of you heard of the book Freakonomics? Or have you read it? I think this is either in that or maybe it's in the next one. There's something about, I know there's a paper that they were looking at the effect of state abortion policies on births, with the number of births. And they were they were looking at the impact of something on the number of births and trying to use state level abortion policies as some kind of an instrument. So maybe it was they were trying to predict the number of births was their X variable. So they know that the state level abortion policies were going to be correlated with that. And I think the Y variable is something like something to do with the overall like income in the state or something like that. And they tried to use these and they had something similar. I forget the exact, this is why I should just talk off the cuff. But there was something about state level abortion policies were also weirdly like strongly correlated with some other state policies that were also impacting the Y variable. And so it actually broke down their exogeneity criteria. Like I said, I'll try to bring in some academic papers on Thursday just to kind of pique a little more interest, because there are some really interesting instruments that people have used that you just wouldn't think about. And then we'll kind of rehash a second example that I have in the data set as well, or a new data set as well. But these are gonna be our main two criteria when we're thinking about instrumental variables. All right. Any questions from me about where we're going, anything like that? Okay. So we're in the home stretch. We've got the last topic. Like I said, problem set is really going to be all you have left. That quiz is effort based, really. So just making sure you get on and get it done before the end of the day Friday. So you see both of those things pop up here when I get back to my office. I also just want to say I appreciate the flexibility. I know when you guys signed up for this class, you didn't know we're going to have like a week where you had to replace it with videos, things like that. So I appreciate all of you. I've tried to catch up on all of my emails. If you sent me an email before Sunday, so if you've sent me an email yesterday and I haven't gotten to it, I'm a little backlog there, but I'll kind of work through those this afternoon and tomorrow. If you sent me an email before Sunday and I still haven't responded, send me that email again, so it's at the top of my inbox. Like I said, I think I worked back through everything from the past 2 weeks. Things have been a little bit chaotic in my life. Also, I appreciate your grace if I can't say a word or something in class. I'm operating on a little bit less sleep than I may be used to. So I appreciate your flexibility. My family appreciates your flexibility. So he's already getting, also, because this is stats, 95th percentile, okay? So, all right. So I'll be in my office hours as usual tomorrow. I think, keep an eye on Canvas. I might have to shift them a little bit. So instead of 12:30 to 3:30, might have to be 12 to 3 tomorrow. I'm gonna keep an eye out on Canvas for that announcement. I think that's probably gonna happen. Other than that, we'll see you guys on Thursday.